Good morning, everyone, and welcome to this panel. In today's world, which is becoming more digital every day, it is really important to answer the question, how can we use our most private information in a way that is secure, but at the same time verifiable? And this question can be answered with zero knowledge. And this is a new cryptographic technology that makes it possible that we verify information without actually revealing it. And today, we have a panel of experts who are working in this field. And in our panel, we'll discuss the use cases of this technology, what this technology actually means, and how can we achieve widespread adoption. I will start the panel with some introductions. My name is Maria Eneva-Olms, and I'm the founder and CEO of Ekolance. And Ekolance is a Web3 talent platform where we help blockchain infrastructure companies and protocols onboard builders and get talent to develop new technology. And we also organize online hackathons where we create new innovative applications. I would like to give the word now to my fellow panelists to introduce themselves and then start the panel. Jordi?
Yes, well, hello, I'm Jordi Baylina. Currently, I'm a Polygon co-founder, technical lead there. I built the ZKVM there. I'm a developer, mainly that's what I am. I'm an engineer. I'm a developer since I'm 12 years old, so that's what I like to do. And I've been in blockchain since 2015. I was involved in the beginning of Ethereum in some of the early hacks of Ethereum. I was a white hat there. Then I created a series of startups, companies. I created Giveth, I created Dabnode, I created Ident3, which currently is Privado ID. Then we created Hermeth, and now currently we are in Polygon. And besides that, I've been developing some tooling for ZK like Circom and Snark.js. Yeah, and especially in the last years, the ZKVM, which has been a huge improvement on the ZK tech. In my personal side, I'm living in Switzerland. I'm from Barcelona. I'm living in Switzerland for the last 5 years. Traveling around the world, a couple of kids right now, literally they are 23, 24, so they have their own life. So that's a little bit myself.
How do I follow that? Let me keep it shorter, I guess. My name is Anthony Day. I work for a project called Midnight. We are a layer 1 data protection focused chain with smart contracts you can build in TypeScript, very similar to the friends over at Mina. We have programmable data protection where you can have as much of the logic on your dApp be shielded or transparent, primarily because public chains are too public and there's too much data published for enterprises and large organizations to really bring dApps and business activities on chain. Privacy projects and also private DLTs don't scale particularly well or can't provide regulatory compliance. Mika is around the corner. There's a whole bunch of different use cases around that, which we think ZK is going to be really important for. So testnet launching next week, so please come check us out. And Kurt, over to you.
Great. Yeah, very hard to follow Jordi and Anthony. So I'm Kurt Hemecker. I'm the CEO of Mina Foundation, and we're helping foster the growth of the Mina protocol and its community. Mina is a Layer 1 native ZK blockchain built on recursive snarks and was actually the first such Layer 1 blockchain to go live with zero-knowledge programmability in ZK apps, launched in June. So it's very much really the beginning of the ecosystem, getting builders and developers and users in production mode on our mainnet. And I'll leave it there so we could dive into the discussion, but I would urge people to go check out minaprotocol.com for more info on the technology.
All right. So the first question I think that probably a lot of people are asking themselves, what actually is zero knowledge proof and why are we talking about it? Why is it useful? So Anthony, do you want to answer that?
I'm going to give the non-technical version of this, and then Jordi can give the technical version. The reason I would like to do that first is that I've heard ZK described as a whole bunch of things that is completely unrelatable to regular humans. For example, zero knowledge is magical math. Right? And if you're about to go to your CTO or you're about to go into a business meeting and say, hey, I'm just about to solve all of your application problems with magic, do you think somebody's going to turn around and say, oh, what a good idea. Yes, how much is the monthly rate to use this magic to help solve all of my application challenges? The reality is we need to do better at explaining what zero knowledge can do as opposed to how it works. Blockchain had the exact same problem, and every other technology since has had the same. AI, quantum. Don't explain to me how it works, explain to me what it does. And so the very simple concept for those people in the audience who love Web3, who want to see Web3 scale, or who want to see wider use of the decentralized internet, is just think about send proofs, not data. We have a problem in the world today where we are regularly sending, on a daily basis, sensitive data over the internet, which, granted, is probably relatively secure, to a third party who is to process that information, store it in a database, govern that data, and try really hard to make sure it doesn't leak out into the public somehow. This is a horrible way of architecting applications on the internet. And it is all predicated, the issues are all predicated over sensitive data being shared from one person's computer or a company system to a third party who has to manage it. The value of technology like zero-knowledge proofs is to be able to generate a proof of something, a proof of a credential, a proof of how much funds you have, a proof of that you are solvent, a proof that you have an invitation or a PDF or an NFT, proof of anything, and be able to prove to a third party that that is the case without necessarily letting them know any of the sensitive information. We can go deeper on any of that into really granular use cases, but at the basic level, send proofs, not data. And then the rest of it cascades down. Is that a helpful intro?
Yes, I think so. Maybe we can hear a couple of examples of the actual applications of zero knowledge proof. Who wants to go? Who wants to answer?
Yeah,
Kurt?
I'll take that, and then I'll pass it to Jordi as well. But I think, as Anthony pointed out, it's really the power of it is in the zero knowledge fact. You're just sending a proof that a statement is true, so you're not exposing any of the data. And it's really, the space we're in is super interesting because we can all see like what the incremental use cases are. In 2026, some of you might be aware that they're now in Europe, the European digital identity will become mandatory. Every single European country has to issue a digital identity to its users. So how is that identity going to be used? Well, for people who want to go into a nightclub or a bar, proving that you're old enough to go in without giving away your name, your actual age. So there's ways to protect that data, or if you're transacting online. But there's another aspect of zero knowledge proofs which is also really powerful. The privacy aspect or the data protection aspect, because you're not actually exposing the data, is super powerful. But there's another power too that Anthony also alluded to, and I think Jordi will have more to say on this. And it's an incredible economy of computing power. So, for example, the first use case, which was introduced also on Mina protocol, is the consensus state of the entire blockchain is wrapped up into one small recursive proof that's infinitely recursed. So, what that enables is for validators, block producers, anyone who wants to benefit from participating on the blockchain, you don't need to re-execute every single transaction. And the same goes when you're talking about smart contracts or zero knowledge applications. So you can benefit from the compute that's already been done just by relying on that single proof. And one of the races that we're all in collectively in the industry is how do you improve the power of this technology? And I think we're going to see, again, we can talk about use cases around identity, and we all see these particularly around KYC, but then there's also another world where we don't know what's going to be built yet. And if you think about, when people were building out the first microprocessors, they had no idea some of the applications that would be built out. And, again, collectively, I think the space we're all in, there's kind of 4 reasons people do something. It's faster, better, cheaper, or enabling you to do something new that you hadn't done before that you want to do. But Jordi, I'll turn it over to you. And I think with your background, you have a few things to say.
I think you did a great job describing what zero knowledge. And you see that there is like these 2 big families or 2 big families of applications. I mean, what we call privacy applications and what we call scaling applications. Privacy, we are talking about protecting data. In general, these are proofs that the users generate in their devices, in the mobile phone or in the client. So in general, relatively small proofs in order to, I don't want to say hide. I mean, I would say this concept of selective disclosure. I mean, it's not that you are not you explain it very well. I mean, in order to prove things, one way to prove things is just showing the data. But there is another way to prove things, is that some computation on your data holds. And this allows you to do kind of a query in your data or in a set of data and just reveal the result of that query. And I think this is important because it's selective disclosure of what you're doing. And this is very much the privacy side. In the execution side, and this is when I have to explain what zero knowledge is, where I like to explain because I think that conceptually it's much more easy to understand. And this is this concept of proof of computation. What means for that? So for that is, imagine that you have a program, a computer program, a deterministic program that takes, let's say, 1 week in a supercomputer to run. Well, I have a supercomputer and I want to prove to Anthony that the result, I mean, after running that for a week, I want to prove that that result is okay. I give the result to Anthony and Anthony needs to check that this result actually is okay. So, well, what he can do? Well, the naive way to do it is, okay, let's hire the supercomputer, you spend 1 week more, you test it again, and then you are convinced that you know, but I mean, you need to spend 1 more. But the idea of the zero knowledge is, the idea is that I can send you the result, and besides the result, I can send you also a cryptographic proof, zero knowledge proof in this case, or a proof of computation, a validity proof, proving you that this result is correct. So you just spending very few milliseconds, you can prove that that result is convinced, okay? And the cool thing, I mean, this is the proof of computation, okay? But the thing is that, this is where the zero knowledge, where the things links, is that I don't even need to, so I can give you the result, and I don't even need to, so I'm not revealing the computation, but I don't even revealing you the input. I mean, I don't revealing the input of the program. And this is where the zero knowledge comes, and this is where the privacy comes. In the other case, when you had to run the computation again, I need you to give you the input so you can run the computation again. In this case, I can give you the output of the result, and then you can hide things. And for here, you can hide any computation. I mean, I like to talk more, maybe let's more futuristic applications, but to give you an idea of what can be done, and this is something that it will be possible at some point. So imagine that a system where you can, you pay taxes, and you don't reveal how much you pay. You just prove that what you are paying is okay, that you are following all the rules, that you have all the, invoices, all the movements. You check everything, you have this information. This information is stated in some notaries, in some blockchains, so you have all the information that you need to do your tax declaration, and then you just pay it. You can pay it even anonymously. I mean, you can pay it with and you can prove that actually you are following, and you cannot, I mean, you prove that that's okay, and you cannot trick the system. And this will not reveal any information about yourself. I mean, this is a kind of an example that's definitively possible. Of course, you need all the information that you need to, the declaration needs to be somehow anchored to the blockchain, so you need to be sure that there is some attestations, and this is where the things are coming. But this is definitely possible. This kind of applications can happen, and this is where where this technology can really improve the world. This selective disclosure.
It's a very cool one, and let me bring it back to maybe some more relevant or more recent or current examples. Anywhere where you are looking to transact on-chain, where there is an element of compliance or there is an element of requiring to protect sensitive information. So, for example, if we're commissioning an AML check or a fraud check on a particular wallet, I want to work with an on-chain AML KYC provider. I want to tell them, hey, I have a suspicious wallet. It's wallet number 1005. Please go check whether this wallet is dodgy because we think it's been sanction screened or we think it's been involved in illicit activity. If I'm a regulator, I don't want to tell the person who is checking and scanning wallets that this is a particular wallet that's of interest, because the second I do that, that's sensitive information that the third party now has. Not great. Analogous to that is you're the CIA, right? This is the off-chain example, but again, for relatability, you're the CIA. You want to look at house number 25 on Smith Street. I need to buy some satellite data around what's happening at Smith Street, number 25, for the rest of the week, just to see who's going in and out of the building. I need to pay a third party for that. But I don't necessarily want them to know that I'm looking at 25 Smith Street because they immediately then know that's a house that's of interest to the CIA. So what happens today is the CIA buys an entire town's worth of data, and they surveil the entire town in one go so that they can obfuscate what they're actually interested in. That is the reverse of a zero-knowledge proof. It is all the knowledge. You're gathering too much knowledge to be able to get the one piece of information you actually need. And then at some point later, if you want to disclose that or you need to prove to somebody that you've done so, you can release that information if you choose to, but up until that point, the two parties have complete shielding of the intent and the information. Same thing with DeFi, right? To prevent front running, if I want to put a particular order in or that I want to prove that I have a certain number of funds to make a certain order, I want to do that without the entire market knowing. At the moment, that's hard to do, right? Or if we want to be able to conduct transactions on chain between different banks across different borders, I don't want everybody to see all of the transactions, the order book that I'm putting or the things that I'm putting in the mempool, because people can make decisions based on that. Right? We cannot have global finance on chain with everything being transparent on Ethereum all the time, or everybody being able to audit or correlate what's happening between different transactions on different smart contracts. These things are problems for us today that we're already exploring the use of zero knowledge to help fix. Web3 is transparent. We have espoused that as one of the benefits, but that is also a blocker for widespread adoption. Too much transparency will scare people away. It's not good for business. And at the moment, everybody who's using DeFi, who's transacting without zero knowledge or some form of alternative shielding, is at risk. They're transacting at risk, saying, you know what? It's encrypted, it's on chain, it's fine. In a post-quantum world, that encryption may not be as secure as we think it is, and it's on a blockchain forever. Well, hands up anybody in here whose ENS, whose .eth address is their first and second name. Right? And yeah, no one's putting their hand up, but we're all thinking about it. Shit. Right? Sorry, this is a family show. But if your .eth address is your first and second name, and that's available on chain, and I can go and search you with human readable language, I can now go and find out the crypto equivalent of your bank account and your browsing history. Go change your ENS address real quick, because that's now public information that people can correlate, and it may not be important now, but it may well be important someday. And these are some of the challenges with scaling Web3 that we need to address now, and we believe that ZK is part of the solution to get there.
Sorry about that. But I think, Anthony, you've just outlined exactly why zero knowledge is here to stay and so fundamental to bringing blockchain to mainstream users. And again, as AI moves more and more to the edge and capturing data, so much data around us, like we definitely want zero knowledge baked in to those devices. I just quickly wanted to mention also one use case that I'm really excited about, which is zero knowledge data clean rooms. And if this is a practical example which can be done today, if you think about, for example, a marketing scenario where different companies, either group companies or companies within one brand group, want to collaborate on consumer insights and consumer data, but without having to share or expose all of the individual data on the consumers that they have. So typically this is done today through third-party aggregators. They take the entire data set from one company A, another from company B, they anonymize it and then feed it back. But with zero knowledge, each company can prove that they have certain demographics or user behaviors within their data set, generate zero knowledge proofs of that get then verified on a blockchain that attests that what that company has said is true. And then other groups can then benefit from those same insights without sharing any of the private data for those customer insights.
And that scales into data monetization as well, right? That's not necessarily just a deal room or an M&A type of product. If you get to transacting M&As with on-chain data, which Hermes was I think the first ever M&A deal in Web3. Am I right?
I'm not sure. Probably yes.
I want to believe so. I remember reporting on it at the time that this is really cool. M&A has come to blockchain. But Jordi, I wonder whether we can also talk a little bit about primitives that are being built around ZK too. Because if you look at products like ZK Email or ZK Login, these are really interesting, very cool things where ZK is being used to bring Web 2 style functionality, like login with your Gmail address or your whatever email address you use, to help people build dApps. Are those things that you see and think that's kind of useful? I like that.
Yeah, this is probably one of the things that's changing in the last years, and what's enabling. I mean, the evolution of ZK has been just exponential high, but in the last years, one of the big difficulties traditionally in the ZK is that in order to take advantage of the ZK, you needed to use some specific cryptographic primitives for that. But ZK has evolved so much faster that the idea is that we don't need to go there anymore. I mean, it's a little bit more expensive, and that means that all the cryptographic communications that happens in the world, and this is, I mean, when you are connecting to a web page, you are using a cryptographic protocol to authenticate the page. I mean, you are signing a lot of informations, digital signatures, digital documents. I mean, there is a lot of information, cryptographic information that happens in the current world. The idea is that today, with the current technology, we can take advantage of all this cryptographic information that actually somehow they prove things. I mean, a signature is also proving that you have a key without revealing a key. Okay, so we can take advantage of all this information and put it inside the zero knowledge. So we can make proofs out of all these communications that happens in today's day. And this is possible, and this is practically possible since now. I mean, the technology currently is available today. It was not 1 year ago or 2 years ago.
Yeah, which is nice. That's you're getting then to ZK acting like we said blockchain is successful when it's underpinning applications and no one notices. When ZK is underpinning your login to a dApp, if you have a wallet on Sui today, you can log in with your Gmail account or other accounts. It will create a cryptographic proof of that you have signed in with Google. It will add a little bit of salt to the transaction so it's unique, and you will then be able to log into a Web3 wallet with an email address and a password, which solves a UX problem that most people are struggling with around wallets and passkeys and so on. I think another important takeaway for the audience is that ZK is not magical math. It is usable technology. We've got to tooling and capability that is usable by dApp developers and user today, right now. We've got smart contracts writable in TypeScript. We've got ZK modules and SDKs that can be built in that have functionality that's useful. It does not have to be built by, at least at this point now, we've got beyond the point where using ZK primitives has to be with ZK engineers.
Just one side comment. I mean, there is no magical math. Math is math. Okay, so it's like, it's that. That's I like. I mean, I understand. I mean, ZK of course has some, say, relatively complex and some math that's not easy to understand. I would say it's easier than it looks like, but it's not something that everybody can understand at first chance. But I mean, cryptography is also as difficult. I would say it's even as difficult as the ZK math. I mean, it's a math that's in there. An RSA signature is very complex math.
But these are primitives that are being used today by app developers who are not necessarily cryptographers, but we've made those tools and capabilities available to developers. And I think it's important that the audience knows that ZK tooling is available now. It shouldn't be seen as, oh, that's a bit scary, a bit different. I don't know whether you've had experience with your community, but for app developers from Web 2 who are coming in with JavaScript and TypeScript experience, developing applications that involve the circuit concept of ZK instead of just kind of linear programming is a slight depart. But at this point, if you're a developer and you've still got useful tooling, it's not impossible to get past, right? It's just a new way of slightly thinking about the programming logic differently.
No, and I think it's interesting that projects like Mina as well as Midnight as well have landed on TypeScript, the most popular Web 2 programming framework.
Make it easy for developers.
Make it easy. I think Maria wanted to...
Easy for developers?
Yeah, I wanted to just give an example that is like super simple, I think, to understand how we at our talent platform implemented ZK technology. So essentially what we do is we connect companies with talent, and sometimes you don't really know where the talent comes from, right? There are certain sanctioned countries. So talent usually doesn't want, or people don't want to really disclose their personal information like ID uploaded somewhere, right? But we implemented zero knowledge proof in a way that if you upload your personal information, such as your ID or passport with your face, it's encrypted. So we don't see it. The company hiring you doesn't see it, but I can confirm that you don't come from a sanctioned country. So this technology is available nowadays. And my next question would be, why use this technology and not like something available on the market? Well, because I don't want anyone having or seeing this information, right? It's encrypted. But maybe you guys can say, why would we use ZK technology, not something else, non-blockchain related?
I would say in most of applications, the only way to read away of the ZK tech is about the central authority. So somehow you need a trust on a central authority, and and even in some applications, even that doesn't work. I mean, in the case of scaling, a central authority needs to check it anyway. But so the nice thing of ZK is, I mean, that you can prove things without you prove it yourself. I mean, you don't need a third party that somehow, a reputational third party that somehow
exactly
proves, tells for you what the
and
other...
sees the information, right?
So you can prove from yourself, so this gives you your privacy, it's more autonomous, it's more decentralized, you know, you have much less dependency. At the end, and this is a philosophical thing, and here probably I want to emphasize this, because Web3 is about creating common goods. Web3 is about creating applications that don't belong to anybody, that they belong to humanity. They are there. Look at Bitcoin. I mean, who's the owner of Bitcoin? Nobody is the owner of Bitcoin. When we are creating Web3 applications, this is what we are creating, what we want to create. We want to create public goods, public services that are there, that the people can use it, that you don't need to ask permission to use it. You as a human, you can use it, and they are available. They are not controlled by anybody. They are just there. Internet, for example, is the first try of the humanity to create something that looks like that, and even that has some authorities.
Yes.
I just have a quick question.
Important.
Have we done our job? Do you all believe that zero knowledge is fundamental to bringing blockchain to mainstream user? Raise your hand if you think we've convinced you of that.
No pressure. Kurt is asking you to raise your hands and believe in us. Please put your hands up.
Oh man, I think we have more work to do.
We've got some work to do. I think the ultimate thing, just to build on what Jordi said, is for those banks and regulators and those people working in compliance sitting in the room or listening, with ZK, you can have the public goods of smart contracts and on-chain transactions, but sensitive data never leaves your perimeter. Sensitive data never leaves your system. And yes, data protection is a spectrum, but specifically for Midnight, we started with the promise of, you want to transact on chain, you want to shield sensitive data, you want the data to never leave your system. For regulated industries with sensitive IP, with business-to-business type of transactions, a whole bunch of companies have on-premise computing for a good reason. They don't want their information in a public cloud. They don't want sensitive information in the hands of third parties. They even don't want to send their sensitive data to 2 or 3 multi-parties to do computation. The second the sensitive data leaves your premises or your perimeter, somebody else is able to potentially correlate and take that sensitive data. And so if it's very important or if it's high risk, technology like ZK to help people maintain control of their IP while transacting on chain is super, super important. And these are the industries, right? The digital assets, the high value, the real world assets, the trad, DeFi, TradFi, CDFi, whatever we call it. These are the mass adoption use cases that we want to see happen. But at the moment, they're not there because people think that public chains are too public, privacy chains are not compliant, and sort of DLT consortium chains don't scale well. We can get past that. ZK is a mass adoption machine. And please consider us and do reach out. Jordi is an absolute legend. Kurt has been at this for a lot longer than I have, and Mina are doing amazing things. And if you're interested in Midnight, come check us out too. And Maria, thank you for trying to keep us on time. We failed, but we tried.
All right. Thank you, everyone. And thanks, everyone, for listening. I hope you understood what is ZK and how it is we can implement it in the world and achieve adoption in the Web3 space. Thanks.
Look at selfie, guys. I'm sorry.